Today we talk about a new topic, Euclid's algorithm for finding greatest common divisor. Let a comma b be two integer a greater than b if r1 is the remainder when a is divided by b. R2 is the remainder when B is divided by R1, R3 is the remainder when R1 is divided by R2, and so on. And if Rk plus 1 is equal to 0, then the last non-zero remainder Rk is the greatest common divisor of A comma B. Okay, if I explain this concept by using some simple examples, so I will give you one example so that you can easily understand the statement of Euclid's algorithm. Now I am going to take two positive integer 252 and 198. So I am going to manipulate greatest common divisor of these two integers 252 and 198. Okay, by using Euclid's algorithm. So what we are going to do first, we are going to manipulate greatest common divisor of these two integer. Among these two, which one is more? 252 is more. So you can assume that A is 252 and B is 198. Okay, then we are going to manipulate A division algorithm. Already we know that 252 can be expressed how many times 192? 252 can be expressed 1 times 198. The remainder will be 54. Isn't it? 1 into 198, for example, 252 is divided by 198. 198. So 1 time 198. So the remainder will be 12 8 minus 4. 14 9 5. So the remainder is 54. This is the quotient. And this one is the divisor, this dividend, and this one is the divisor. Okay, so this is your A, this is your B, Q, R. So how we are going to write A in terms of BQ, PQ plus R, division algorithm. I can express the same thing here. Okay, after that what we are going to do? That means when A is divided by B, R1 is the remainder. Here the R1 is the remainder when A is divided by B. Second step, B is R2 is the remainder when B means 198. B is divided by R1. Here R1 is 54. R1 is 54. So R2 is the remainder. R2 means here the remainder when B is divided by R1. So that means 198 is divided by 54. How many times 54 there in 198? So 54 into 2, 108. 54 into 3, 54 into 3. How many times 54? 12 into 1, 15, 16, 162. 54 into 4 is 16. 20, 21. So it is more than 198. So 3 times only. 3 times 54. So 162. The remainder is 36. 8 minus 2, 12. 6, 9, 6, 3. So how we are going to write here? 36. How many times 54 in 198? 3 times 54. So R2 is the remainder when B is divided by R1. Isn't it? And third step, R3 is the remainder when R1 is divided by R2. R1 is divided by R2. R3 is the remainder. R3 is the remainder when R1 is divided by R2. That means 54, 36. How many times of 36 in 54? 1 times only. So 36. Remaining is 18. So how we are going to write 54? So 1 times 36. The remainder will be, here you can replace 18. So 1 into 36 plus 18. So R3 is the remainder when R1 is divided by R2. So next what we are going to do, we can stop the process until you will get the remainder is 0. So 36, this one, what is R2? R4 is the remainder when R2 is divided by R3. So 36, how many times 18? 2 times 18. 2 into 18, 36. The remainder is 0. So you can stop the process here. Once you will get the remainder 0, you can stop the process there. So what is the greatest common divisor? A non-zero remainder. If rk plus 1 is equal to 0, then the last non-zero remainder. This is the last non-zero remainder. So 18 is the greatest common divisor of 252, 198 is 18. So this way you can manipulate greatest common divisor of two positive integer by using Euclid's algorithm. Isn't it? Any doubt in this? Yes. Okay. Now we move on to the another problem. Find the greatest common divisor of 120, 500 by using. So I can two different way you can manipulate greatest common divisor. The first method is prime factorization. Second method is Euclid's algorithm. Okay, we will discuss one by one. Okay, prime factorization. Already you know that prime factorization. How we are going to write prime factorization? Every positive integer can be expressed uniquely as a product of prime factors, isn't it? So how we are going to write 120? 120 can be expressed as a product of prime numbers. So 120, you can start, the first prime number is 2. So 2 into 60, another prime number 2, you can write it in the unique way. Okay, 30 into 2. So once again 2, 15, 3, 5. So how we are going to write 120 as a prime factors? 2 into 2 into 3 into 5. So in this way you can write the prime factors. So this will be equivalent to 2 cube into 3 into 5. Similarly, you can write 500 also. By using prime factorization, you can write the prime factors of, you can start from 2. So 2 means 250. Am I correct? 250 times into 2. Once again 2. What is the answer? 125. Next, this 2 is possible? No. 3 is also not possible. The next least prime number is 5. 5 means 25 times 125. Once again 5, 25 times. So how we are going to write to 200, 500? 2 into 2. 5 into 5 into 5. So this is equivalent to 2 squared into 5 cube. Here I can manipulate greatest common divisor by using prime factorization. For that we are going to write the prime factors of 120 and prime factors of 500. After this, what we are going to do? See here, the power of the prime 3 is not there in 500. So I am going to include 0 exponent of the prime number 3. So that means 2 squared 3 power 0. 0 exponent of the prime number 3 I can include 5 3. So next I can manipulate prime GCD greatest common divisor of the two positive integer 120 and 500 is. So this is the formula. Prime number minimum of A comma B. Next prime P1 minimum of. So minimum of A comma B, A1, B1, A2, B2 and so on. Pn minimum of An comma Bn. So what do you mean by A1, A2 and all? P power. This is equivalent to P power A1. Prime numbers. P is nothing but PQ are all prime numbers. Okay. So from this, how we are going to write greatest common divisor of these two numbers? P1. P1 means minimum of. Here the first prime is 2. So what about the power of 2 in 125, power of 120? The power of 2 in 120 is 3. Here the power of 2 in 500 is 2. So 2 power minimum of 3 comma 2. Similarly, next prime number is 3. The exponent of the prime number 3 in the 120 is 1. So minimum of 1 comma 0. Next prime number is 5. The power will be minimum of 1 comma 3. 1 comma 3. Isn't it? See here the power is 1. Here the power is 3. The prime number 5. The power of prime number 5 is 3. Okay. So this is equivalent to 2 times minimum of 3 2. So 2. 3 times minimum of 1 comma 0 0. 5 minimum will be 1. So the answer is 4 into 5. This will be equivalent to 20. So in this manner, we are going to manipulate greatest common divisor by using prime factorization. The same problem, I can use Euclid's algorithm also. Euclid's algorithm, 120. Here I am Euclid's. Okay, Euclid's algorithm. Okay, so already we know that Euclid's algorithm means first we are going to manipulate. We have to check the two positive number, which one is more than the other. So here 500 is more than 120, so I can manipulate 500. So how many times 120 in 500 you can use? So what we are going to do, we can divide A by B. We can divide A by B. So 500 divided by 120. How many times 120 will be there in 500? 4 times. So the answer will be 480. Okay, so the remainder is 220. So how we are going to write? 124 into 120 plus 20. When A is divided by B, the remainder will be 20. Okay, so next what we are going to do? B is divided by, how will you get the remainder R2? This is R1. The remainder R2 is obtained when B is divided by R1. B 120. When B is divided by R1, 120 is divided by 20. So how many times 120 will be there? 6 times. So 6 into 120, 0. So 6 into 120, 6 into 20, the remainder is 0. So once you will get the remainder 0, you can stop the process there itself. Then last non-zero remainder will give the greatest common divisor of the two positive integer. This is 20. We got the same answer. Okay. In this manner, you can manipulate greatest common divisor by using prime factorization as well as Euclid's algorithm.